Hey guys, this is the start of the 5.1 note. So, topic 5. This one deals with nth roots, radicals, and rational exponents. Okay. Um, what we're first going to do is find all the real nth roots. Okay. So, what are all the real nth roots? Meaning, say squares or cube roots or things like that. In this example, it says, what are the real cube roots of 125? Okay. But, right, and let's kind of go through the definition. So an nth root of a number C is x, such that x to the n is equal to c. And an nth root can be denoted by a radical symbol with an index. Okay, so these are kind of just terms of n, and then you'll see n, and then the radical of c, and then the c is called the radicand. Okay, so this is kind of just formal definitions. Now, all right. So it says to represent the real cube root of, say, 125, right? We're going to write x is equal to, and then you'll see, right, the 3 because it's the cube root, right? The radical, and then the radicand, or the thing we're trying to find the root of, is 125, so that goes right there. Okay, so we want to find the value of x such that, right, what cubed gives us 125, right? Because we're taking the cube root, we're trying to find what number cubed gives us 125. Well, to solve this, right, to solve x cubed is equal to 125, the answer, right, is 5 cubed, right? Because 5 times 5 times 5 gives us 125. Okay. Now, but we want to consider if there are other solutions. Okay. So to determine this, what we need to do is set the expression equal to 0 and factor. Okay, so our expression was x cubed equals 125. So we're going to set that equal to 0, so minus the 125. And now we're going to factor this. Okay. Now, this one's a little difficult, so I'm going to kind of go through the factor of it, but it's a special case, right? Actually, let me go back. Right, remember, our a would be equal to x, and our b would equal 5, right? Because we can cube them, right? And this is the difference of cubes. So our difference of cubes formula, I'm going to kind of write over here, should be a minus b times a squared plus ab plus c squared. Oh, sorry, b squared. All right. So we're just going to rewrite this and factor it using that formula. Okay, so a is x, so x minus 5, because b, times a squared, so x squared, right, plus 5x, because a times b, right, a is x, b is 5, and then plus b squared, which is 5 squared, 25. Okay. Now, what we need to do is set these both equal to 0. Okay, find the solution. So x minus 5 equals 0. So x equals 5, right? And that's one of the solutions we already found. Okay. Now we need to see if this gives us a real solution. Okay. To test that, we use our discriminant. Okay, our discriminant, remember, back is b minus 4ac. Okay, and right, if it's greater than 0, then we have 2 solutions. If it's equal to 0, we have 1. If it's less than 0, then we have no real solutions. Okay, so I'm going to plug in 5 for b. Right, oh, sorry, it should be b squared. So 5 squared minus 4 times a, which is 1, and our c, 25. So we get 25 minus 100, or negative 75. So, right, that's no real solutions because it's negative. Therefore, right, x equals 5 is our only solution for this. All right, so let's just do one more to kind of give you a little more practice on this. So, right, we're trying to find the fourth, all the real roots for the fourth roots of 16, right? So that means x to the fourth is equal to 16, right? So we set that equal to 0, and we need to factor. Okay, so if we factor this, you should get x squared plus 4 times x squared minus 4 is equal to 0. And then we can't factor this one anymore, so that needs to stay there. But we can factor this one right here to x plus 2 times x minus 2. So right here, we set these x plus 2 equals 0, x minus 2 equal to 0. We get x equals negative 2, x equals 2 for solutions. And then, right, we can also set x squared plus 4 equals 0. Well, you're going to get x squared equals negative 4, right? We can't take the square root of a negative number, right? When we do that, we're going to get some imaginary number, right? Remember, we get plus or minus 2i technically, so we're only looking for the real roots. So we're not going to use these roots. We're only going to use these solutions. So the two real solutions for x to the fourth is equal to 16 would be negative 2 and 2. All right, so I want you guys to try these on your own, but I will give you the solutions. So this one should be negative 3 and 3. And then this one should just be 4. Okay, so try these on your own. If you have questions on them, ask me and I can give you the solutions for these. The steps. I give you the solutions. All right, the next part of this section deals with rational exponents. So meaning a number raised to a fraction, okay, and how we can interpret them and how we rewrite these things. Okay, so it says, what is the meaning of the exponent in the expression 16 raised to the fourth? Okay, so to interpret rational exponents, we're going to look at what happened if you extend the properties of exponents to rational exponents. So what we do here, right, is what we're going to do is raise our 16 to the 1/4. Okay, and what we want to do is we want to write it and figure out what number to the fourth power is going to give us 16. Why to the fourth power? Well, because we're looking at this n right here. Okay, in this case, in this problem, our n is equal to 4, right? Because it's 1/4. So the number under that 1 is what we're trying to look for, right? So we're trying to look for what number to the fourth power gives us 16. Okay, well, if we do 2 to the fourth power, we get 16. So we're going to rewrite this as 2 to the fourth power instead of 16. And then we're going to raise 2 to the fourth power to the 1/4. Okay. Now, right, when you raise a exponent to an exponent, right, we multiply them. Okay, so 4 times 1/4 gives us 1. Therefore, when we raise 2/4 to the 1/4, we just get an answer of 2 to the 1, or just 2. And if we think back to the last example, right, we said that 16 to the 1/4, right? This can also be written as, right, the fourth root of 16, okay? And that's essentially what we solve for. We solve for the fourth root of 16, meaning what number to the fourth power gives us 16, right? So x to the fourth equals 16, right? And we solve for x essentially in this problem. All right, let's look at another example and try and solve this one. All right, so what is the meaning of 27 to the 2/3? Well, 27 to the 2/3. All right, we're going to rewrite this, okay, as a fraction with just 1/3, okay, because we want to take just the third root. Okay, so how do we rewrite that? Well, we're going to do 27 to the 1/3. Okay, so it's just the third root of 27. And then we also need to put the 2 on the outside, because 2 times that 1/3 brings us back to the original 2/3 fraction right here. Okay, but we want to write it in this form so that we can easily find this cube root of 27. Right, and then we'll use the square at the end to figure out the final solution. Right, so now, right, let's change this to the cube root of 27, what was in the parentheses, and then leave that squared on the outside. The cube root of 27 you can use your calculator for, but it's what number cubed gives us 27. So what number times itself 3 times gives us 27? Well, that is 3, right? Because 3 times 3 times 3 gives us 27. So I change my parentheses to 3, and the squared is still on the outside. And now 3 squared is 9, and that's our solution. Okay, so what this is saying is 27 to the 2/3, right, is also equal to 9. Right, so we're just kind of writing the expression in a different way and simplifying it. All right, so I want you to try these examples on your own. A should be not too difficult for you, right? It's to 1/2, so that means you're taking the square root. Right, for B, just remember to change this to 32 to the 1/5, so the fifth root squared to solve. Okay, and then it should be just like that example B we just did before. Okay, your solutions, if you want them, would be 5 here, and your solution here would be 4. Okay, so try those on your own, and if you have questions on how I got the solutions, just ask me on Remind, and I can send you the steps. For these problems right here, just to evaluate these, you're just gonna want to rewrite them and then put them in your calculator, and then you'll get the solution. So, right, this one, we're gonna rewrite this as negative, right, and then we're taking the fourth root of 16 and then cubed, right? So this number, this 3 goes on the outside, right? This is the root we're taking, and then this is the number that goes under the radical. Okay, you can simplify this because you should know the fourth root of 16 is just 2. And then you can just plug that in your calculator and you should get -8. This one, right, we have a decimal. So, right, all you have to do is take the fifth root of 3.5. Okay, and then once you do that, right, you put it to the fourth power in your calculator, and you should get a solution of 2.72. Okay, so this is just if you want to put in your calculator and get a expression. If you need help putting in your calculator, well, I'm assuming you probably don't really have a calculator home. You can just put this in like Google Calculator. All right, so those were how we simplified using numbers. Now we're going to use actual expressions and simplify them. Okay, so what we're going to do is we're going to first try and rewrite our radicand, so the thing under our radical. Okay, so how can we do this? Well, we want to figure out, we're taking the fifth root, right? So what number times 15, what number times that 5 will give us this 15, right? Well, 5 times 3 will give us 15, okay? So what we want to do is we want to rewrite the radicand with an expression to the fifth power, okay? The reason is because we're taking the fifth root. If we have something to the fifth power, we can take it out, okay? So every 5 pieces we can technically take out is what I'm trying to say. So let's just rewrite this. So we're going to rewrite this as the fifth root. And then we're going to take out a fifth power. Okay. Now, that means we're looking at this piece right here, and we're going to take out the fifth power of each one. Okay. So we need to take the fifth root of 32. So the fifth root of 32 will be 2. Okay. So that goes here. Then we need to take the fifth root of m to the 15. Okay. So when we take the fifth root of something to the 15th power, we need to rewrite it as how many times 5 goes into that 15. Well, 3 times, so we're going to rewrite this as m to the third. Okay. So all we did was rewrite this as this right here. Okay, because if we distribute this fifth power back to the 2, it'll change back to 32. And if you distribute the fifth power back to m cubed, it'll change back to m to the 15. All right, now, because we have them all to the fifth power, what we can do is we can cancel out the fifth power and the fifth root, and it just leaves us what's left in that parentheses, which is 2m cubed. All right, so I know that's a lot of steps, but it will get easier the more you do this. All right, so let's try B, okay? Again, last one, we rewrote the radicand to the fifth power. This one, we're going to rewrite the radicand to the fourth power, okay? So it's going to look something like the fourth power of something to the fourth power. Okay, so right, what we need to do is figure out how we get x to the 20th, right, if we take out a fourth power, and how we get to y to the 8th if we take out a fourth power. Okay, so again, we're taking the fourth root of x to the 20th and the fourth root of y to the 8th. All right, and that's what's going to go in our parentheses here. Okay, so the fourth root, right? So what times 4 gives us this 20? Well, that'd be x to the 5th. And then what times 4 gives us y to the 8th? That'd be y squared. Right, so that's what goes in our parentheses. Now that we have that, our fourth root and fourth power cancel out. We have x to the 5th, y squared. Okay. Now, the only thing is that whenever we square something, we know our answer is going to be positive. Well, we want to find only the real nth roots. So if we have a exponent like x to the fifth, we need to put an absolute value around it, okay? So if we have an odd exponent, we need absolute value, right? Because we cannot have a negative number in here at all, okay? So our final solution, we would just have to write as the absolute value of x to the fifth y squared. And that's our solution. All right, let's look at the other examples. So I was gonna have you try these on your own, but I feel like we should do a couple more. Okay, so this might be an easier way to write these. So again, we're taking the cube root. So what we want to do is take each term. So let's look at the -8. We want to get it cubed, right? So that the cube root and that cube cancel out. Same with that a term and same with the b term. Okay, so maybe each term write a parentheses and a cube, right? So for the next problem, right, we're doing the fourth. It'd be something to the fourth to cancel out. Again, something to the fourth to cancel the x's, and same thing for the y's. Right, so now we want to find out what cubed gives us -8. Right, so that means -2 cubed gives us -8. What cubed gives us a cubed, right? Just a, right? A cubed gives us a cubed. And then what cubed gives us b to the 9th power? Well, that's b to the 3rd power. So again, right, this might be easier because you're setting up each term and then you're figuring out what's going to be left over once you can cancel out the cubes. Right, so now we can cancel out all the cubes, and what's left over is just -2 a b to the 3rd power. Okay, so that kind of probably seems like it's easier than before. All right, now we're doing to the 4th power. What to the 4th power gives us 256? If you don't know this, you can Google what's the 4th power of 256. Right. It is 4, because 4 to the 4th power gives us 256. And then x to the 3rd power will give us x to the 12th, because 3 times 4 gives you 12. And then y to the 6th power, because 6 times 4 gives us this 24. Right. And now we just cancel out all the 4's, and what's left over is 4x cubed y to the 6th. Okay. Now I know I mentioned absolute value before. One reason we're going to put an absolute value here is because, right, the original x term was even, okay? It was x to the 12th, so it was even, so it had to be positive, right? But our new x term was x cubed, which is odd, right? Because it changed to odd, that means it could be negative, right? But in the original problem, it had to be positive because it was x to the 12th power, okay? So to make sure that we keep our x positive, so to make sure x is positive, right, what we're going to do is put the absolute value. All right, now this is the last type of example we'll really see. We're going to do one real world after this, but if we look at this problem, we're going to be solving equations using nth roots. Okay, so to solve this equation, what we're going to do is we're going to take our 2x to the 5th right, is equal to 54. And what we're going to do is start solving for x. Okay, so we divide both sides by 2. We get x to the 5th is equal to 32. And now because we need to take the 5th root to solve for x, we're going to raise both sides to the 1/5 power, right? Because we know 1/5 is the same as taking the 5th root, or like something like that, the 5th root of x. All right, so we raise both to the 1/5, and when we take the 5th root of 32, we should get 2, because 2 to the 5th power equals 32. Let's go through A and B real quick. So A says 5x to the 3rd equals 320. So divide by 5 to both sides, we get x cubed equals 64. And then we raise them both to the 3rd power. 1/3 power. And so we get x is equal to 4, because 4 to the 3rd power gives us 64. Right? And you can always check that. Make sure 4, right, plug in 4 right here. It should equal 64, and it does. Right? So when we have an exponent to an odd degree, so like cube, we're going to get one solution. Right? You'll notice on this next one, we're going to raise, so b right here is 2p to the 4th equal to 162. Right? We're going to notice, because it's even, we're going to get two solutions. Okay, so we get p to the 4th, right, is equal to 162 divided by 2 is 81. Now we do p to the 4th to the 1/4, because we're taking the 4th root, and 81 to 1/4, or 4th root of 81. Well, remember when we used to take square roots, we always got two solutions. Same thing with to the 4th root to the 6th root. Anytime you have an even exponent, you're going to get more than one solution. You're going to get two solutions. Okay, so for p, we're going to get plus or minus 3, because if you do 3 to the 4th power, you get 81. And if you do negative 3 to the 4th power, you also get 81. That's why we have two solutions for it. And I know this is long notes. That's why I'm giving you multiple days to go through this. So for this problem, we're looking at the volume of a soap bubble is this certain amount of millimeters cubed. Find the radius and diameter. Okay, so we need to first know the volume formula. So our volume formula is approximately 4/3 pi r cubed. Well, it is 4/3 pi r cubed, but what we'll do is we'll use 3.14 for pi. So 4/3 times 3.14 r cubed. All right, but we're given the volume, so I'm going to write the volume in as 492.6. And now we're just going to solve this just like we did in the last problem. So let's multiply our 4/3 and 3.14. So we get 492.6 is approximately equal to 4.187 r cubed. Right, divide both sides by 4.187. This gives us about 118 on the left side, and then just r cubed, right? And then we take the 3rd root to solve, so raise them to the 1/3, and we get r is approximately equal to 4.9. You'll have to just do the cube root of 118 in a calculator, right? And then we know the diameter of a circle is just double. So equals 2 times the radius. So it's approximately 9.8. So again, this is a long note section, so take your time on this. Make sure you ask me any questions. I can resend you stuff, or I can send you more videos helping you with this stuff.